Alright, so continuing here in 6.1 with some angle measures with some trig, we're taking a look at radians now. So 1 radian is equal to the radius, but that distance on the outside of the circle. Okay, so we're talking about the distance on the outside of the circle is a radian. So for example, the radius, right? This is the distance of a radius. So roughly, if we were to take that like a string and fold it over, that is a radius. So that's the same distance as the radius. And if we keep going around, that's how you end up making a circle. It's 2 pi radians, because there's 6.28 radians roughly. That's 1, 2, 3, 4. If we keep taking that string and putting it 5, 6, and then that little portion is about 2/8 of a radian.
What do you want?
So 180 degrees equals pi amount of radians. So 180 equals pi. To switch to degrees, here's how you switch from degrees to radians. You got to remember this, so make sure you write this down. From degrees to radians, it is pi over 180. Why? Because then the degrees will cancel out, leaving just a pi left over. To switch from radians to degrees, it's not that much more challenging. It's just now 180 over pi. That's all. So some extra examples here. Switch this to radians. So here's what you do. To switch it to radians, since this is degrees on top, that means I put degrees in the bottom. So that's 180 degrees and pi on top. So the degrees end up canceling out. So I end up with 150 over 180 pi. So all you got to do is simplify that. Just use your calculator, do math frac. So you can type that in, press math, then frac, then there you go. But the zeros cancel out, so you get 15 over 18 pi, and I can actually divide a 3 out of both those. So that is 5, 6 pi, or 5 pi over 6. So 7 pi over 4, what would you do there? How would I take that and write that into degrees? Well, since we have a pi on top, that means I'm going to put a pi on the bottom and 180 on top. This way the pi's cancel out. Then I can do 7 times 180 and divide that by 4. So it's 1260 divided by 4, which is 315 degrees. Okay? So common radians and degrees, and you will need to memorize these. You will need to keep these to memory because you will run into these frequently, so you don't have to continuously sit there and try to remember, or sit there and try to switch these back and forth from degrees to radians. 0 radians and 0 degrees are identical. Pi over 6. So like I said, keep these in memory. Pi over 6, you can do the math, you can solve it, but just memorize these. It makes trig easier. Pi over 6 is the same as 30 degrees. Pi over 4, the same as 45 degrees, and I normally remember this because it's over 4 and it starts with a 45 fours. So pi over 4 is 45. Pi over 3 is 60 degrees, so here's how I remember this. The pi over 6 is 30 degrees, pi over 3 is 60 degrees. They're kind of opposites. They don't go together. Like this one goes together with over 4 and 45. 6 and 60 don't go together. They're actually opposites. Pi over 6 is 30, pi over 3 is 60. Pi over 2 is 90. 2 pi over 3 is 120 degrees. 3 pi over 4 is 135 degrees. 5 pi over 6 we just did, that's 150 degrees. Pi is 180 degrees. 3 pi over 2, that one is 270 degrees. 2 pi is 360 degrees. Common ones to remember. Guarantee if you're in my class, I'm giving you pop quizzes on this. I am giving you pop quizzes to put these imprinted into your brain so that you have these memorized. These are the most common ones that you will ever run into, so you don't have to do the work to try to translate things and move them back and forth. So, figures with radians. Pi over 4, alright, we said that's 45 degrees. Well, if this is 0 and that's 90, 45 is right in the middle. Okay, pi over 3. I said pi over 3 is 60 degrees, so it should be a little higher, maybe like around here. But once again, if that's 0 and that's 90, that's 60 degrees. 90 degrees is straight up and down, that's pi over 2. 180 degrees is a straight line, that's pi. 180 degrees right there. So if theta equals 3, what is it in terms of degrees, minutes, and seconds? So 3 is radians, so I need to switch a 3 to degrees, which means if that's radians, it's pi over 180. So 3 times 180 over pi, so it's 3 times 180 over pi. So when we do that, we end up getting 171.887338.5. The problem is we need minutes and seconds as well. I have the degrees. The degrees is definitely 171 point something. So that's why, if you notice, I pulled this apart. I have 171 degrees and I have that 0.887338.5 all there by itself. So how do I take that and switch that into minutes and seconds? So I take the 0.887338.5, that decimal, and you switch the decimal to you switch this decimal by multiplying it by 60, because how many minutes are there in an hour? There are 60 minutes. So I take that and multiply it by 60 to get roughly 53.24031, which means how many minutes are there? 53 minutes, which leaves me with a decimal of 0.24031. Okay, well, how many seconds are there in a minute? There are 60 seconds. So I take this and I multiply this by 60. So I get 14.4185. Now there's nothing after seconds. We just do degrees, we do minutes, we do seconds. Okay, so I'm going to have to round this. So it's 14.4. So we're just going to say it rounds to 14 seconds. So basically what you do is you find it as a decimal. Then you take all the decimal garbage that's left over and you multiply it by 60. Then you take all the decimal garbage that's left over, you multiply it by 60. And then last but not least, you have to round it to make sure. So if this was like 0.5, it would actually be 15 seconds on the M. Okay? So just something there to keep in mind. So change that into a decimal now, going backwards. 19 plus, okay, this, how many minutes did we say were in an hour? 60, so 47 over 60 plus, because there are 60 minutes in an hour. How many seconds are there in an hour? 3,600, right? Because in 1 hour you have 60 minutes, but then there's 60 seconds in each minute. So 60 times 60 is 3,600. So basically it's 19 plus 47 over 60 plus 23 over 3,600. And when you add all that together, because there are 60 minutes in an hour and 60 seconds in a minute, so it's like double that. But when you do that, you end up getting 19.78972222. Alright, so not a hard section. The section was mainly based on switching, right? Mainly switching things around. Pi over 180 and 180 over pi, and memorizing those degrees is the biggest thing. Okay, so remember that stuff for this section. Not a hard section to get you started in trig. We'll eventually get to the right triangle stuff here coming up. Okay, but keep that stuff in mind. And if you have any questions or concerns, please let me know.